all the line needs. Although the new miniature circuit breaker 5SL impresses with its attractive design, every aspect is designed with functionality in mind. A colored switching positioning indicator with plain text display is integrated in the operating handle, allowing the switching position to be clearly seen. Another advantage is the ergonomically designed handle, which simplifies operation a great deal. A touch protection is integrated in the terminal. This offers reliable protection against electric shock and thus helps to increase safety when connecting devices. The terminal design is clear and compatible with all other miniature circuit breakers. The hand-operable latching slide enables easy positioning on and removal from the standard mounting rail. This helps to speed up installation thanks to the time-saving snap-on fixing system. The bus bar is attached at the rear. The feeder cable is connected at the front of the bus bar. This ensures that the connections are clearly laid out and easy to identify at all times. With the aid of the snap-on fixing system, assembly devices can be quickly removed from the bus bar without the need for tools. The additional auxiliary switches and fault signal contacts can be attached to the MCB 5SL at any time. They are fixed using a captive bracket. A handle locking device can be easily applied and protects against unauthorized switching. The handle locking device can be secured with a padlock.
When an electric current is passed through a conductor, a small voltage drop is created across the element and some power is dissipated as heat. If the current increases, the heat generated also increases. Do you know what happens when the temperature increases? Let's see an example. We know that ice melts as the temperature increases. The same thing happens to the conductor. When temperature increases beyond the threshold point, the conductor melts. This is the basic principle behind the electric fuse. A fuse is an electrical safety device that has a metal wire that melts when too much current flows through it. This metal is made of zinc, copper, silver, aluminum or other alloys. How this fuse protects our circuit? This fuse is connected in series with the circuit to be protected. So the current flowing through the fuse and the circuit will be the same. When overcurrent flows, the metal melts and so the circuit is totally disconnected from the source. Thus the fuse will prevent the overcurrent to flow in the circuit by sacrificing themselves. Today we have different types of fuses. One of the most familiar fuses is rewirable fuse. They are simple fuse used in homes and offices. They consist of a carrier and a socket. When fuse is blown, the carrier is taken out, rewired and put back in the socket to resume normal operation. We have to be very careful while selecting a fuse for our circuit because if we select a wrong fuse, the safety is not ensured. For example, if we use a fuse that blows at 10 amps to protect our circuit which operates at 12 amps, then what happens? This fuse blows even at the normal operating current. So, while choosing the fuse, the current rating of the fuse should be greater than the normal operating current of the circuit. Similarly, when a short circuit occurs and overcurrent flows to the circuit, then the fuse should blow safely without fire, breakage or explosion. Therefore, the breaking capacity of the fuse should be greater than the short circuit current. Another important parameter to consider is speed. I mean the speed at which a fuse blows. It depends on the material the fuse is made. For example, semiconductor devices requires ultra-fast fuse as it heat rapidly when excess current flows. Similarly, a time delay fuse are designed to protect equipments like motor. Now, let me ask you one question. Do you think we can use the same fuse for AC and DC circuits? The answer is no. In AC circuit, the magnitude of the current becomes zero many times a second. A zero current is very easy for a melting fuse to stop. But in DC, the magnitude of its current will never become zero. Therefore, fuses have to take the full responsibility with no help from current. So, DC fuses are more complex and have many different internal elements.